Origin Chess, home UX, and this black hole could be bigger than the universe. But Kurzgesagt in a nutshell. Here's another Kurzgesagt video, and this is about black hole. Yeah, it's like ongoing series on black hole. He probably made a ton of black hole videos. Pretty sure I watched all of them. So yeah, this is gonna be insane. I don't know which. I mean, I'm pretty sure he covered everything there is to be about black holes. So I'm gonna guess it's like more of a something different type of thing or some kind of a thought experiment. I don't know. Kurzgesagt is awesome. Obviously, Kurzgesagt covers like a scientific topics, but also like topics like thought experiment and things like that, fun things, right? So yeah, it's gonna be interesting. Let's watch it. Remember, if you like my reaction, don't forget to subscribe. So that way I know which type of videos to react to more. I like scientific topics like this. I allow channel like Kurzgesagt. So if you want me to do more reactions like this, definitely comment down or whatever, like, comment, whatever that is, right? The more interaction I guess this video gets, that way I'll know which type of videos to do or not. Let's watch it.
We proudly present to you the Kurzgesagt Guide to Curiosity. Join us on an interactive adventure across 160 thrilling pages that will change your perspective on the world forever. Available now on the Kurzgesagt shop. You might be inside a black hole that's inside a black hole that's inside a black hole. Everything in existence could be black holes all the way down. It turns out black holes are much weirder than you think, and they break the universe much more than is usually explained, destroying time and space. And they may actually create infinite universes in the process. But before we can get to that, let's first build a black hole out of air. Everything can become a black hole if you squeeze it to a critical limit. You'd need to squeeze Earth down to the size of a coin for it to turn into a black hole. The Sun needs to be squeezed down to the size of a small city to become a black hole. And if a lot of mass is concentrated in a really tiny space, you get something super dense. This is usually how black holes are explained. Stuff becomes super dense and collapses into a black hole. But actually, you don't need any ultra-dense stuff to make them. We're ignoring some maths here, but all you really need to know is one thing. The larger black holes get, the less dense they are. So, really large black holes are kind of thin.
Yeah.
A sun mass black hole is only about 6 kilometers wide and has a density of about 1 Himalayan range per cubic meter. The supermassive black hole at the center of the Milky Way has a mass of 4 million suns, a diameter of 24 billion kilometers, and a density of 6 blue whales per cubic meter. The ultramassive black hole IRIS 2100-4156 has a mass of 3.8 billion suns and is as wide as the solar system. But because it's so large, it is only as dense as air.
Yeah.
This means, at least in theory, that if you take a gigantic balloon and fill it with undecillions of...
Yeah, obviously, I'm pretty sure I've seen somebody, I don't know, was it on YouTube, comment or something, say like, okay, this is a supermassive or ultramassive black hole, which is like less dense than water. So if you were to drop that inside of water, would it like float? And I'm like, I get it where you're coming from, but literally thinking what you're saying, if you were to take a volume of water that is like wider and bigger than this ultramassive black hole, the water itself would collapse and become even bigger black hole. It would consume that other black hole, right? But the point is here, like density. I mean, it makes sense, right? About this density thing. But, people, I don't know if this is like general knowledge or not, but obviously when like event horizon is nothing but like a gravitational boundary, let's just say, of the black hole, right? It's not an actual object, right? It's where light doesn't escape. So event horizon, and obviously gravitational force like tied to the mass, right? So let's say if you have like a black hole that is like, let's just say mass of 1, right? Now if you double that, right, the event horizon's radius would get double as well. But as you would know, like if you were to take a sphere and double that, the volume doesn't double. Volume becomes like much bigger number. So the volume of black hole would be like 10 times as more, 8 or 10 times more, rather than double, right? So the event horizon became double, but the volume it became 8 to 10 times more, so density goes down, right? So event horizon, there might, this, I don't know when it comes to black hole, everything, like all of our physics basically collapses. So if there is like a thick object there in the center of it, what is happening, what is singularity, right? All this theory out there. So past event horizon, there might be nothing there, right? It's just the point where gravitational force is so strong, light can escape, but we take that as a boundary. So that way density gets lower and lower as it becomes bigger.
Tons of air. The moment it gets to the size of a solar system, an event horizon suddenly forms and it turns into a supermassive black hole, without violence or squeezing. So now, let's think big. What do we need to make a black hole the size of the universe? A universe-sized black hole. The chunk of the universe that we can see from Earth is a sphere with a radius of 45 billion light-years, filled with hundreds of billions of galaxies, lots of gas, and a bunch of other things. If you add them up, it has the mass of about 1,000,000,000,000,000 suns, which sounds a lot, but on average, the universe is not very dense.
Yeah.
If we break up all the galaxies, stars, gas, and energy and spread them equally inside the volume of the universe, we get an average density of about 5 hydrogen atoms per cubic.
Yeah, it's insanely thin, right? I don't know which scientist was that. I forgot his name, right? What I was basically in a lecture said this, right? Like, how many molecules are there in like interplanetary gap, right? Compared to that, how many molecules there are like interstellar gap, and compare the same with intergalactic gap, right? It becomes insanely. Intergalactic gap is like few molecules, right, per mile or something. I don't know what the exact number was, but yeah, it's insane, right? How empty everything is, even with this kind of like a number. Even though like billions and billions of galaxies, there are more empty space than there are matter, right? So yeah, this just, that's it. Per cubic meter, that's all there is, right? It's insanely thin.
Meter. You can imagine this as the sort of ultra-thin cosmic air that makes up the universe. What would happen if we take a balloon as big as the observable universe and fill it with cosmic air? Well, it turns out that all the mass in the observable universe is more than enough to create a black hole. Actually, it's enough to make a black hole 10 times larger than the observable universe. But that can only mean one thing. We should be living deep inside a truly gargantuan, cosmic-sized black hole. There's one catch, though. We know that our universe is expanding, and an expanding universe is not what you'd expect to see if you were inside a black hole. So our universe can't be a black hole.
I mean, it might be our perception, right? I mean, look, gravity bends space, right? We know like event horizon, like, gravity bends space. But if we were to walk straight through that, we would turn, but we wouldn't realize we are turning, because we are in space, right? If space itself bend, we won't realize it's bending. That's why the lensing effect is there, right? It looks like the light is coming straight, but it's coming from the side because like space is bent. So even though we think it's like expanding because we are in space, right? But that might be one of the effects of black hole, who knows?
At least not in the naive way we've just described. Except there's a wild and mind-bending trick the universe could play on us. To find out how, let's jump into a black hole and die. A whole universe born inside a black hole. We usually imagine black holes as spheres with a singularity at their center, a point where all their mass is concentrated so much that our maths breaks down. But this is a lie. They are so much weirder. From the outside, a black hole looks like a normal black sphere, but the inside is where things stop making sense. Black holes warp the universe so much that at the event horizon, space and time switch their roles. Inside a normal sphere, space is finite, but time goes on forever. But inside a black hole, it's the other way around. Space goes on forever, but time is finite. So once inside, you see...
This is one of those places where our physics fails. So, this might be real, this might not be, right? We are looking at it with whatever Einsteinian physics we have, right? But Einsteinian physics might fail at this point, or we need to expand it in a different way, or not, right? This might be just as weird. Things doesn't have to make sense to us, right? That's the one thing in science. It doesn't make sense to us. It doesn't have to if it like makes sense on the paper eventually, right? But to me it feels like this is where the science is kind of failing at the event, at the center of like black holes and things, right? Where singularity feels very weird, like sci-fi episode or something, right? So to me it feels like we need like just like how Einstein expanded Newtonian physics, we need something to expand Einsteinian physics.
See an infinite universe with no center. The geometry is too complicated, so we're simplifying. But basically, you could walk forever in one direction or walk in another direction and arrive at the same place again. But not only that, inside a black hole time is finite and it's now running out. So after a while, you start to notice that space itself is slowly changing. In one direction, space is being stretched, while in all other directions, space is shrinking. The whole universe is being squeezed, kind of turning into a collapsing spaghetti. Sooner or later, the whole black hole universe collapses into itself. All of space, every single part of it, is turning into a singularity. So the singularity of a black hole is not at its center or in any direction at all. It's in the future of whatever falls inside. We made a whole video about this if you want to learn more. So the singularity is not a place where you can go, it's an event in time that happens. Once it happens, you and everything else that fell inside the black hole will be mercilessly crushed into an infinitely small region with infinite gravity and infinite energy. Time, space, none of it matters anymore. Both kind of stop existing in ways that we would recognize. And then, is this the end? Well, maybe not. This collapse of the black hole universe into a singularity looks like one of the scenarios for the end of our universe, the Big Crunch, where long after the Big Bang the whole universe collapses into a singularity again. But if there's a big crunch, there might be a big bounce, like a rubber ball that you've squeezed too much and that suddenly
Big crunch is kind of like sounds similar. I'm pretty sure the concept was different, right? I don't know. I mean, look, we are taking a lot of liberties here with the theories. Obviously, it's a thought experiment. Of course, we're going to do that. But to me, this feels like, nah, that's probably not going to be the case, right? I mean, I don't know, man. I get it. Like, there is a point in like black hole, you get spaghettified, right? But because this black hole is so bigger, you're not at the point where you get spaghettified, and like physics around is like twisting so much way, like he explained, like we haven't reached the singularity yet, right? So 13 billion years that we experience is still like ongoing point to that, and in future we will reach a point where we reach singularity. But to me, this was like probably not. But then again, anything could be possible. So yeah, as a thought experiment, yeah, it makes sense.
Rebounds, space might expand again. So a new universe could be born inside a black hole. The funny thing about this scenario is that nothing has changed in the slightest outside the black hole. Watching from the outside, it's still a black sphere of nothingness. And yet, on the inside, a new universe has been born. So maybe our universe was born like this, and we are all actually inside a black hole. But if our universe can also create black holes, they might give birth to new universes. Is our black hole universe also just part of a universe further up that's also a black hole inside another universe? Is there an end to it? Is there one original universe? Is the cosmos black holes inside black holes inside black holes? Infinite black hole universes. If the universe creates black holes that create universes, that then create new black holes that create new...
The answer to that is, maybe. Go ahead, sleep well. There you go. That's what the answer is.
New universes, this cosmic self-reproduction would be subject to natural selection. A Big Bang is a chaotic and messy event, so it's possible that the new daughter universes would not always be fully identical to their mums. Sometimes physics may be slightly different, with some fundamental values higher or lower, and so some universes might be able to create loads of stars, planets, and black holes. Others might not, maybe creating a uniform cosmic soup where no stars, planets, and black holes form. But if...
Yeah, I think if you're gonna... I don't think so, man, right? Because we haven't experienced any different physics from any black holes, right? And look, like I said, event horizon is just a place where like light can escape. Doesn't mean there's actually something there, right? So if like a less dense, larger, supermassive black hole, there will be a point where like singularity matter, whatever the center of it is there, and other part is just like where light can escape, but it's still nothing there. That's why it's less dense, right? So in the end, there is a point where you get spaghettified, right? So existing inside a black hole, that just feels kind of weird, right? I don't know about that, right? Because we haven't seen anything that would tells us like anything physical that we have would survive inside a black hole, right? Everything's spaghettified all the way to quarks, right? So as a thought experiment is great, but I don't think so. Like black hole inside a black hole is like another universe, right? And the matter that we have right now, somehow the black hole that we can see, that's where it gets spaghettified. But we are inside a black hole and we are not spaghettified. It's just like we are a complex, like organism. I don't know. That doesn't work.
If all universes are born inside black holes, in the long run, all universe lines that don't create loads of black holes would die out. The universes with the conditions for loads of black holes would become the most common and spawn the most daughter universes. Survival of the fittest, but with universes instead of organisms. Our observable universe alone has created at least 10 to the power of 17 black holes so far. So maybe our universe has the physics and laws it has because it was born after a long process of cosmological selection that favored the production of tons of black
Yeah,
holes.
but that would imply all the other black holes that we have in our universe would show some kind of a difference in physics. And I mean, sure, it could be. We haven't like really studied black hole that in detail. I mean, whatever we can, we've studied it, right? We haven't like observed a black hole by going close to this, obviously. But I don't know, like nothing shows that black holes have different kind of like physics to it. So this would require that there are different type of black holes in our own universe. But yeah.
And that would have a lovely side effect. If universes are optimized to create as many new black hole universes as possible, they're optimized to create loads of galaxies and stars. And thereby also, by accident, the conditions for life to emerge. So universes that are the best at creating new universes are also the best at creating life. If this scenario is true, who knows how many bazillions of black hole universes might be out there, all with stars and planets potentially home to others like us. So, is our universe like this? The truth is we don't know. While these ideas are based on real science and work on paper, they're speculative and not testable. Also, cyclic universes don't actually explain why the universe exists in the first place or why it is the way it is. Instead of providing answers, these are really just new questions in disguise, so keep that in mind before getting too excited. But isn't it just wonderful and heartwarming that we're living in a universe where ideas as big as this one are even thinkable? There might be so much life. And if new universes are created constantly, maybe life will go on forever. We've heard rumors of a chosen one, a special verb who has the
Hey, about go to original video page link and from there support this channel. It's an awesome channel. Does a thought experiment like this, which is great. Yeah, I mean, in physics, one thing we notice that like things sometimes is like really like simplified, right? I mean, everything can be simple, like put to like periodic table. Everything is just there, right? Carbon life is just like connected. DNA, we share DNA with most of the, like life on the planet, right? Things usually have a way to simplify in a way in like physics, right? So when we see a black hole that we can't explain, and then we see like Big Bang or the, like origin of life we can't explain, it's like easier to like connect those two. Like what if those are two connected? It just works, right? It's just how all the discovery we made kind of feels like that, right? Like connected in a way. That's why string theory exists in the first place. Everybody's trying to connect everything, right? But yeah, I don't know about that. But yeah, it's a good thought experiment. Well, this black hole could be bigger than the universe, but it's not because of that in a nutshell. If you like my reaction, don't forget to subscribe. Yeah, I'll see you next time.